Okay, so here's what'll hopefully be a short video over an introduction to the trig derivatives. We're going to look at sine and cosine and tangent, and then your homework will be well, tangent and secant, and then your homework will be to come up with cotangent and cosecant on your own, and maybe a little extra. I don't know. I'll see what I come up with the worksheet. But the easiest way to do the proof for sine and cosine's derivatives is actually to think of this graphically. Um, there are plenty of proofs online and videos of people going through the whole issue to do it, but it takes about 10 minutes to go through the whole proof of what the derivative of sine is. I'm going to try to do it in like 2 minutes. That way we get an idea, but we don't have to go through all the work of limits and everything. So here's what I've got. I've got the graph of sine right here as a function. Here's the sine function. And what I've got set up on GeoGebra is that as I slide this point A here, it moves the tangent line to the graph along the curve. And then point A here actually is, let me show the label. I should just turn that on. Properties, show label, and I'll show value. Okay. What that is the value of A for the x value, and the y value is the value of the slope of the tangent, which here's the equation of the tangent line. So at this point here, the equation of the tangent line is negative 0.49x minus 1.19. This point here says when x is negative 4.2, y is negative 4.9 or 0.49. So again, the slope matches the y value here. So that's what this point is. The y value of this point is the slope of the tangent, meaning that's the value of the derivative, because the derivative is the slope of the tangent line. So as I move this graph, it only goes so far because I didn't want it to go forever, but you can see it bounces up and down. In fact, let's animate this guy. There we go, it moves on its own now. So hopefully, as you're watching this, you can see that the y value, or the slope, however you want to think of it, has a very specific set of values it goes between. -1, back up, positives, +1, back down 0. So hopefully you catch, hey, wait a second, the values for the slope, or the y values here, are always between -1 and 1. Hey, what functions do we know that have y values like that curve back and forth over and over again? There's your big hint. So let me turn off this animation, and let me turn on the sketch of this, the trace of it, and now I'll animate it and watch it trace that point. And there we go. We're getting the graph here of the derivative created by the computer. So again, 0 slope, +1 slope, 0 slope, -1 slope, 0 slope. So you can see it's crossing through at zeros, -1, 0, +1, 0, -1, and then back to 0 again. So I'm going to turn off the trace. Okay. And what's going to happen is a quick question is going to pop up and ask you, what do you think is the equation to this graph? And you'll just type in what you think it is. And then once we get to that, I'll go over what it is actually. So, yeah, let's let you go to that. Okay, so we're back. Hopefully you said, that looks like cosine, which is what it is. Okay, so if I'm going to just plug in now y equals cosine x. And there you go, you can see it matches up with it perfectly. So the derivative of sine is actually cosine. So sine's derivative is cosine. Now, I'm sure you'd think to yourself, oh, wouldn't it be great if the derivative of cosine was equal to sine? So that would be the hypothesis I would have. Well, let's take a look at that then, because I've got it set up over here as well. So same situation. Here's the graph of cosine x. Here's the equation of the tangent line. I didn't turn this point on. I should have probably done that ahead of time. So object properties, value, there we go, done. So you can see here, okay, here's the point. The y value is the value of the slope, so it's the tangent slope. So again, what I'll do is I'll trace this guy and I'll animate it. And we'll see what the graph looks like here. Now this time, again, it's got a curve this time. But the problem is, if you remember the graph of sine x should be going through 0 like it does here, but it should be going upwards. So this guy isn't sine 0, but it's very similar to it. So just like before, I'm going to pause it, you type in what you think the equation is, and then I'll show you what it really is. So animation off, oops. There you go. Okay, so here we are back again. Hopefully you said y equals negative sine of x, because that's what it is. It's not the sine of x. Here's y equals sine x, and I'm going to be running out of spaces here. So you can see there's sine, but it's not sine, it's the opposite of sine, so it's reflected across the x-axis. So there we go. So the derivative then of cosine of x is negative sine x. Okay. Now, to be honest, these are the only derivatives you have to have well, you have to have all of them memorized for all 6 trig functions. But as far as the ones we can derive, like without using all the limits and stuff, these are the 2 you have to know. Because every other derivative you can actually come up with in terms of using one of our rules you've already learned and using these 2 derivatives. So I'll show you that now. So what I'll do is I'll do the derivative of tangent. Okay, so I want to find the derivative of tangent. So dx of tangent x. Okay. Now the first thing you have to do to find the derivative of tangent is actually rewrite it as sine x over cosine x. Okay. We're going to do the quotient rule here because we're going to come back and use these derivatives here and some trig identities to come up with tangent x. So quotient, this is your numerator, this is your denominator, so the rule is derivative of the top times the bottom. Well, the derivative of sine was cosine of x times the denominator, which is cosine x, minus the numerator times the derivative of the denominator. Well, the derivative of cosine x was negative sine x, all over the derivative squared, or the denominator squared, sorry, all over cosine squared x. So when I simplify that, this is cosine x times cosine x. Oh, that's cosine squared x. And then negative sine x, that cancels out to be plus, and sine x times sine x is sine squared x, all over cosine squared x. So now you have to say to yourself, hey, I know a trig identity that deals with cosine squared x plus sine squared x. That identity is that sine squared x plus cosine squared x is 1. So I get then 1 over cosine squared x. Now, the next step to the derivative of tangent is realizing, oh, well, that's really 1 over cosine of x quantity squared. And what function is the reciprocal of cosine? Well, that would be secant. So the derivative of tangent is actually secant of x squared, or the way we write it is secant squared x. So there we go. There's the derivative of tangent. Okay. Now, to do cotangent, you do the same thing, but you just flip that and do cosine over sine. So that's one of the things I'm going to leave you with as homework to try to sort out on your own what the derivative of the derivative of cotangent is. Now the other one we could do is the derivative of secant. Okay. The derivative of secant. So d dx of secant. Well, that's d dx of 1 over cosine of x. Okay. So what we're going to do is the same thing as before. I don't want to do this with the chain rule. I'm going to do the quotient rule here. So the derivative of the top is 0 times the denominator minus the top times the derivative of the denominator. And again, the derivative of cosine is negative sine x. And then it's over the denominator squared, which is cosine squared x. Okay. That cancels, the negative drops off, and I get sine of x over cosine squared x. Now, if you look at this, you might go, that's not really any kind of trig identity that I know of. And you're right. What I really have to do is treat this as sine x over cosine x times cosine x, and then split that up as sine of x over cosine of x times 1 over cosine of x. And then you have to go, oh, well, what's sine x over cosine x? Oh, that's tangent x. And what's the derivative? And what's 1 over cosine x? That's secant x. Okay. And then for some reason, I don't really know why, but we don't write it as tangent x times secant x. We write it as secant x times tangent x. I don't know, maybe it's because it's alphabetical, or maybe because you've already used secant. Okay. So there's the derivative of secant x. So for your homework then, okay, for your homework, you got a worksheet that I gave you in class with this. But just to kind of summarize what we've gotten so far. Okay. The derivative of sine x was cosine of x. Okay. The derivative of cosine of x was negative sine x. Okay. The derivative of tangent of x was secant squared x. Okay. And the derivative of secant of x was secant x tangent of x. Okay. Now, your homework is to go back and do what I did for cotangent and do what I did for cosecant, or for secant, sorry, for what I did for tangent and what I did for secant, and then do the same thing for cosecant and cotangent. So d dx of cosecant of x and d dx of cotangent of x. Okay. And then, yeah, so that's to try to see if you can figure those out. Okay, great, thanks.